Let's make together a dough with 100% hydration. Hi, I'm Sergio. I'm a professional pizza trainer from Italy based in France. And this experiment is not to show off or just to give you a recipe, but it's to help you understand some of the most fundamental notions that are behind pizza making. The achievement of this experiment at 100% hydration depends exactly on those notions. After all, those notions are the same that applies to every pizza dough that we can make. But here, as the gluten has to withstand much more hydration than usual, these notions are more critical and they played an important role in the achievement of the pizza that you will see. The video is split in two. In the first part, the longer one, we're going to look at the actual recipe, following each step in the process of making the dough. Next, we're going to analyze those notions, those important learnings about the dough that are critical here for this recipe, but they apply in any way to all other dough. Before going to the lab, let's look at the recipe details first. Okay, so let's start with the flour. In this case, for this experiment, I used a strong flour. We'll discuss later on the reasons for that, but just to let you know, I used a white flour, so a tipo 00 or type 00, with the W index of between 360 and 380. The hydration, we know, it's the point of this experiment, 100%. And I used around 0.7% of yeast. So in other words, 7 grams of yeast per kilo of flour. And in this case, it was fresh yeast. Salt, just a standard dosage, 2.5%, so 25 grams per kilo. As regards the actual process that I followed, I did a 24 hours bulk fermentation at controlled temperature, the fridge at 4 to 6 degrees. And after the dough shaping, I left the dough at room temperature for about 4 hours before baking stage. Let's start this experiment with kneading. So I'll begin with the flour, which in this case is a strong Manitoba flour, the yeast, and the first part of water. You might have noticed that there were ice cubes in the water, even though the ambient temperature was around 20 to 22 degrees Celsius. So why the ice cubes? The goal here is to achieve a very high hydration, 100% as we said, and it's extremely important to start with a low temperature so that we can increase the temperature while still staying within an acceptable range. In fact, it would be very difficult to finish the kneading and form the gluten correctly if, while kneading, I end up with the dough at 30 or 32 degrees Celsius after just 20 minutes of kneading. So the point is to start very cold, which is why I used ice cubes. If you're wondering why I used a strong flour, the answer is very simple. Since I'm going to make a very hydrated dough, I need the flour that is capable of retaining this amount of water. Plus, I need the flour that can give me enough elasticity and tenacity given this high hydration. So I decided to use a Manitoba flour, even though it's not at all suitable for classic pizza dough. But in this case, I had no choice if I wanted to get to the right gluten. What's extremely important in this first part is to structure the gluten well. This is something I repeat very often in my videos, but it's something we analyze in detail in the training courses. If you don't structure the gluten properly at the beginning of your kneading, the gluten will not be able to absorb the rest of the water to start with, and the dough will lack the elasticity needed to hold together well. The first part of kneading is finished, so here I've just added the salt. Everything went well, as you saw. In the first part of kneading, we're still at a medium hydration level, around 70%. I add just now the salt and a drop of water, and I'm going to switch to the second speed. I'm going to add the remaining 30% of hydration to reach the 100% just now. I've increased the run per minute of my spiral mixer to over 200 RPM. And we're going now to add the water little by little. The video at this stage will be at higher speed so you can really see how the dough evolves throughout the second part. By now I've reached around 80% hydration, and you've seen that I'm also starting to check the temperature from time to time throughout the kneading process. The idea is simple. I have to keep the dough temperature very cold to easily achieve 100% hydration. So as you saw, I measured first 18 degrees, then 19, and the last time was 20 degrees. I will measure it again throughout the second part of kneading.
The goal is to reach, by the end of kneading, the ideal range of temperature for the gluten, which is 23 to 25 degrees Celsius. What's really interesting to see here, thanks to the high-speed video, is that the dough is starting to spread and relax more and more into the mixer. This isn't because the dough is hot, as you can see it's still around 20 degrees, but because we're starting to have a very high hydration, which causes the gluten to relax more. The second part of the kneading is now complete, and here is the final result. The first thing I'm going to do is to check the temperature. I'm at 24, so temperature-wise we're good. And that, as I said, it's one of the things that allow me to achieve 100% hydration here at this stage of kneading. Checking the network is well formed as well. Despite the fact that the gluten is relaxed and a little sticky, I can still pull the dough away from the bottom and feel a certain elasticity in my hands, which tells me effectively that the gluten was indeed well formed. I'm now removing the dough from the mixer bowl. I will divide it in several pieces, and once again you can see that the dough is not liquid. It looks very relaxed, but it's still quite elastic, and when I pull it like this you can still see some tension. I fold it a few times to shape it into a dough ball. I'm now going to put my dough into the container. After 45 minutes I came back to rework the dough directly into the container, so I folded a few times to give the dough a little more strength. The dough needed it because, as you saw, it was very relaxed. It's time now to let it rest for 24 hours in the refrigerator for its bulk fermentation. After 24 hours, this is how the dough looks like, and I'm gonna start the shaping of dough balls. Despite the hydration, the dough is easy to work with, thanks of course to the good kneading, but also thanks to the good bulk fermentation. Right here, I'm just using semolina. I'm not using any flour. The dough ball size I'm choosing here, it's around 210 grams. After shaping the dough ball directly into the semolina, I'm going to give it a bit of tension on the work surface. And here, my dough ball is ready. As you saw, the movements during shaping were really quick. So when you have a dough that sticks a little more, don't spend hours with your hands stuck to the dough. It will only make things worse and make the dough very sticky, of course. The best way to work with this kind of dough that's maybe sticky or high hydration is to do very quick movement. Now, once the dough ball is ready, I'm gonna let it rest for a few hours at room temperature. In fact, there is no need to put it in the fridge with this hydration, given the fact that we're gonna give it even more extensibility, and we don't want that. It's now time to do the stretching directly into the semolina. The first thing I noticed was that the dough had a really excellent texture and strength. In other words, I managed to give the dough a good elasticity and tenacity, which you can see from the fact that the dough doesn't spread too much, isn't too stretchy or too weak. On the contrary, the edges are retaining the fermentation gases well, and the dough is really not difficult to stretch. So how did I achieve this kind of result with 100% hydration? Obviously, as we said earlier, the strong flour played a role. The kneading as well made a difference. Kneading correctly and forming the gluten properly during kneading allowed us to achieve this result. The second thing was that the recipe that I used here was adapted for this type of dough. It was not at all a recipe for classic pizza. Instead, the fermentation was managed differently, with the bulk fermentation that was quite important and a short fermentation for the final proofing. Time to do the toppings. Here I just kept it simple and I added just some tomato sauce and then onto the peel and straight into the oven. As regard time and temperature for the baking stage, I set the temperature of the oven at around 350 degrees and the baking time was around 3 minutes and 30 seconds. I basically didn't want to do a Napolitan baking style as the dough would have suffered this high hydration. And here it is, the final result. So overall the development of the crust is quite remarkable. I'll add just a bit of Parmesan cheese, basil, and I'm gonna cut the dough to analyze the gluten structure. In the interior, the crust is very light with a low density, so overall we can say that this experiment is successful. But what is very interesting right now is to look at the key learnings. So it's time now, as we said, to look at the key learnings from this experiment.
There is, in my opinion, a fundamental notion which allowed me to achieve this result, but it is true for any pizza dough. And that is that the right gluten structure of our dough ensures a successful result. What I mean by the right gluten structure is, of course, a gluten that is balanced in its tenacity and extensibility, so that it has the good elasticity for our final product. And so this is the key objective every time we make our dough. We need to get to the right gluten for our final product. And here, this experiment with 100% hydration demanded a really elastic gluten to work correctly with the 100% hydration. And so the question is, where can we control this gluten structure? Those are the 4 essential elements where we can actually manage and control the gluten structure. It's during kneading, in the choice of the flour, choosing the hydration, and of course during fermentation. So what we will do right now is we're going to analyze each of those 4 elements, except hydration, of course, because that was a fixed parameter. And for each of those parameters, we're going to see what are the key learnings, what have we learned from this experiment. And so let's start with kneading. Of course, we discussed throughout the video the importance of this step, but essentially there were 2 learnings here. The first one was that I managed to achieve this 100% hydration because I had the right spiral mixer with the right performance in terms of round per minute, RPM. If you remember, I went up to 200 RPM, even above, in order to correctly knead my dough and to let the gluten absorb the water. The second learning regards temperature. We discussed it, but here we're gonna really highlight this learning, the importance of keeping temperatures under control during kneading. In our case, for this 100% hydrated dough, it was very important to keep, especially at the beginning, the dough quite cold. You saw that I started measuring the dough from 18 to 20, even after I included the salt. And that's because having a cold dough allowed me to have a more compacted structure and to avoid to lose completely my gluten in the spiral mixer. Even though you saw the dough was quite relaxed, quite loose in the mixing process, I managed to give it enough elasticity. And that was really thanks to those 2 learnings, to those 2 elements combined. Good spiral mixer and the temperatures that were under control, quite low in this case. Let's go into the flour. And so there was a fundamental learning here, that is the performance of the flour, especially when it comes to the W index. The W index here that I choose, if you remember, is quite high, around 360 to 380, was high enough to ensure the absorption of water during kneading, but also the right tenacity and elasticity throughout the recipe process. So the W index of a flour always needs to be adapted to the product that we're realizing. Here, for 100% hydrated dough, I had to choose a strong flour. And last but not least, let's look at fermentation. Why fermentation here? It's important because fermentation changes the elastic properties of gluten. And so we need to manage correctly fermentation. In particular, the learning here was that it's important to adapt the fermentation process depending on the elasticity balance in terms of tenacity and extensibility that we need for our product. You understood by now I need quite elastic dough to work correctly with 100% hydration. And so what I did here, on top of using the right flour, on top of kneading well my dough, is that I give the dough an important bulk fermentation combined with a shorter final proofing time. Okay, and those 2 fermentation stages helped me achieve a dough that was quite elastic with a good tenacity so that it could work well with 100% hydration. And let me remind you as well that here this concept applies whether it's a direct dough, as it was the case for this recipe, or also for an indirect dough, whether we're using Polish or biga. We've come to the end of this experiment on 100% hydrated dough. I hope this video helped you get a better grasp on the important notions that are behind making a pizza dough. The key message is that if you want to master your dough, you need to look at your gluten. You need to look at the elasticity of the gluten and control all the variables that were listed in this video in order to get to the right gluten. It's only when you get to the right gluten that you're gonna have the right dough for your product. And so if you want to learn more about how to manage properly your gluten in order to get to the product achieving quality and regularity, I suggest you look at my professional pizza training The link is just here in the description. You will learn, in fact, a methodology to achieve this quality, to achieve this regularity and consistency by understanding the gluten and understanding how to control it. I'm Sergio, I'm a professional pizza trainer, and thanks for watching. Ciao e buona pizza!